Chapter 9 is where the hypothesis testing begins. We start with just one sample hypothesis testing. So in this chapter, we will learn to test claims about means and proportions. We will see the relationship between confidence intervals and hypothesis testing. We will learn to understand the limitations of hypothesis testing and how errors can occur. And this chapter just allows us to test claims about one sample means and proportions. And this is where our fun really begins with the inferential statistics. One job of a statistician is to make inferences about populations based on samples. Confidence intervals are just one way that we can do this. Another way is to make a claim and then test it based on a sample. This is called hypothesis testing. There are 6 steps to doing a hypothesis test. First, you have to set up 2 contradictory hypotheses. Then you want to design a study, collect your sample data, and then determine the correct distribution to perform the hypothesis test with. You will then analyze the data by performing calculations that will allow you to ultimately reject or not reject the null hypothesis. Then you make a decision and write a meaningful conclusion. These are the 6 steps that you will follow when you're completing your research project in this class. There are 2 contradictory hypotheses. First, the null hypothesis. This is a statement about the population parameter that is either believed to be true or is used to put forth an argument unless it can be shown to be incorrect beyond a reasonable doubt. Then there's the alternative hypothesis. It is the claim about the population that is contradictory to the null hypothesis, and this is what we conclude if we reject the null hypothesis. Now, the null hypothesis will always contain an equals part. And since the 2 hypotheses are always contradictory and cover all possibilities, the following sets of hypotheses are possible. A two-tailed test, where we have an equal sign in the null hypothesis and a not equal sign in the alternative. A right-tailed test, where the null hypothesis has a less than or equal to sign, and the alternative hypothesis has a greater than sign. Or a left-tailed test, where the null hypothesis has a greater than or equal to sign, and the alternative hypothesis has a less than sign. Now, when you're writing these hypotheses, what's written as mu sub 0, pronounced mu naught, would be a number. Some number that you're proposing the mean is equal to or not equal to, or that it's less than or greater than, or less than or equal to, or greater than or equal to. So this would be filled in with a number. When you're trying to determine if you have a right-tailed or left-tailed test, or if it's two-tailed, you want to look at the alternative hypothesis. In the alternative hypothesis, if you have a not equals to sign, it is a two-tailed test. If you have a greater than symbol, it's pointing to the right. So that tells you it's right-tailed. If you have a less than sign in your alternative hypothesis, it's pointing to the left, so it's a left-tailed test. There are only 2 decisions that can be made as a result of a hypothesis test. You can choose to reject the null hypothesis or do not reject the null hypothesis. The decision is always made about the null hypothesis, rejecting or not rejecting the null hypothesis. These are your only 2 choices. So let's practice writing some hypotheses. If we want to test whether the mean GPA of students in American colleges is different from 2.0, let's write the hypotheses. Different from would lead us to think not equal to. So we'd have our null hypothesis, mu equals 2.0. Alternative hypothesis, mu does not equal 2.0. What if we wanted to test whether the mean height of 8th graders is more than 66 inches? The null hypothesis would be mu is less than or equal to 66. And the alternative hypothesis would be that mu is greater than 66. If we want to test if college students take less than 5 years to graduate college, less than 5 would be seen in our alternative hypothesis then. So we have our null hypothesis is mu is greater than or equal to 5. Alternative hypothesis is mu is less than 5. When a hypothesis test is completed, there are 4 possible outcomes. First, your decision could be do not reject the null hypothesis, when in fact the null hypothesis is true. Now, you're never going to know if the null hypothesis was true or false, but in this case, you made a correct decision. You could decide to reject the null hypothesis, when in fact the null hypothesis was true. Now this would be an incorrect decision, but you wouldn't know that you made that incorrect decision. And this leads to a type 1 error. A type 1 error happens whenever you reject the null hypothesis when the null hypothesis is true. The third possible outcome is that you do not reject the null hypothesis and the null hypothesis is actually false. This again is an incorrect decision. It's known as a type 2 error. A type 2 error occurs when you do not reject the null hypothesis, when the null hypothesis is false. The final decision is the decision to reject the null hypothesis, when in fact the null hypothesis is false. This again is a correct decision. And the probability of this occurring is called the power of the test. The probability of a type 1 error is said to be equal to alpha. We're going to see alpha more later on. The probability of a type 2 error is equal to beta. Now the power of the test is equal to 1 minus beta. Ideally, we want the power of the test to be as high as possible. To increase the power of the test, we will want to increase the sample size. Now, if we were to increase the power of the test, that means the probability of a type 2 error goes down. So a larger sample size, the more powerful the test is, and the smaller probability of having a type 2 error. Now, we get to choose alpha for our test. It is equal to 1 minus a confidence level. This is also known as the level of significance. So alpha and the level of significance are the same, and they are equal to the probability of a type 1 error, and you get to select alpha for your problems. So by increasing the sample size and increasing our confidence level, we can decrease the probability of an error occurring in the hypothesis test. We can never get rid of it though. There are 2 distributions that we will have to choose between when testing one sample. These 2 distributions we've seen before, the student t distribution. It's used when we do not know the population standard deviation, and we assume that it's an approximately normal population, or it's a large sample size. And then the normal distribution. We're using the standard normal distribution here, and this is used when we have the population standard deviation. We assume that's approximately normal or a large sample size. We also use the normal distribution when we are testing proportions. So a few more things that we need to know before we can jump into hypothesis testing. We need to talk about rejection or the critical region. we have a two-tailed test. It would look like this. There'd be two critical values and two rejection regions. If our test value falls between those two red lines, we would make the decision to do not reject the null hypothesis. But if our test value is out in the tail area, we would make the decision to reject the null hypothesis. A left-tailed test has a critical value that is off to the left. If our test value is out there in that left tail, we would reject the null hypothesis. Otherwise, we do not reject the null hypothesis. Right-tailed tests, as you can see, look very similar, only they have a rejection region in the right tail. Now, we probably want to know where these vertical red lines occur at, right? Because that tells us whether or not we're rejecting or not rejecting our null hypothesis. So how to find the critical region? There will be a value at those red lines that separates the critical region from the non-critical region. This value is known as the critical value. It's often abbreviated as CV. The critical region is determined by the level of significance that you select. The level of significance alpha is the area in the critical region. This is also called the tail area. So alpha is the amount of area in the tail. Now we have found z values before when we had area to the left of the value we were looking for. We can use this same method when finding critical values for a standard normal distribution. Critical values should always be from the standard normal distribution if we are using it for our test. If we are using the student t-distribution, we would want to find t-values. If we have a left-tailed test, the area to the left of our critical value would be alpha. If we have a right-tailed test, the area to the left of our critical value would be 1 minus alpha. If we have a two-tailed test, the area to the left of the left critical value would be alpha over 2. Now that right critical value would be the positive of that left critical value because this is centered at 0. Now, we have some steps that you will follow when you're just performing the actual test. The first thing that you always want to do is to state your hypotheses and identify the claim. The claim is whatever you are being asked to test to see if it is accurate. Please remember that the null hypothesis always contains an equal sign. Second, you want to select a value for the level of significance and then find the critical value or values. The critical values help you make a decision about whether or not to reject the null hypothesis, so you do need to find these. Third, you will compute a test value. The test value will be found based on the distribution that you selected. And then you want to make a decision. You make your decision by comparing the test value to the critical value, and this helps you make the decision. The decision is always either reject the null hypothesis or do not reject the null hypothesis. Then you'll write a sentence summarizing your results. Now I do have some guides to help you write this sentence so that your sentence is correctly summarizing what you have found. Your final conclusion sentence should always be about the claim. Now, at this point in the test, you've made your decision, reject the null hypothesis or do not reject the null hypothesis. So this is going to kind of dictate how we start to write our sentence. If our claim was the null hypothesis and we decided to reject the null hypothesis, we would say there is enough evidence to reject the claim. We'd want to go ahead and finish the sentence stating what the claim was. If our claim was the null hypothesis and we had made the decision do not reject the null hypothesis, then we would say there is not enough evidence to reject the claim. Now, what if your claim was the alternative hypothesis? Well, that changes the wording, because our wording is always going to be talking about the claim. So if we had decided to reject the null hypothesis and the claim was the alternative hypothesis, we would be stating there is enough evidence to support the claim. If our claim was the alternative hypothesis and we had decided do not reject the null hypothesis, our sentence would be, there is not enough evidence to support the claim. This little guide to writing your final conclusion sentence is something that I recommend that you write down and have easy to find in your notes. This will be very helpful for the rest of the semester. Now, there's a second method for completing a hypothesis test. This second method is called the p-value method. You state your hypotheses and identify your claim. The claim is whatever you're being asked to test to see if it's accurate. And remember, the null hypothesis always contains an equal sign. We then select a value for the level of significance. For this method, we do not need the critical value. Next, we compute a test value and a p-value. The test value and p-value will be found based on the distribution that you have selected. Next, we would make a decision. We make a decision by comparing the level of significance and the p-value. Remember, the decision is always either reject the null hypothesis or do not reject the null hypothesis. So comparing alpha to p, if alpha is less than p, we make the decision do not reject the null hypothesis. If alpha is greater than or equal to p, we reject the null hypothesis. And then we write a sentence summarizing the results the same way that we did with our previous method. Now, how would we find p-values? Well, we could use tables or calculators to find p-values. P-values are the probability of being in the tail area beyond the test value that you calculated. I have a feeling, though, that at this point in the semester, you've had enough of doing things by hand. So let's go ahead and grab our calculators and learn some functions that will be useful for finding these t-values, z-values, and then ultimately our p-values that help us make decisions. So grab your calculators, go to Stat, then over to Test to find the following functions, and this is if you're using a TI-83 or 84 calculator. There's a z-test. Z-test is used for normal distribution tests about means. A t-test, students' t-distribution tests about means, and then a one-prop z-test. This is for normal distribution tests about proportions. Now, I am going to show you how to do it by hand as well as do things on the calculator so that you can use either method. I know some of you still don't have a calculator at this point in the semester, and that's okay because we do have formulas to do things by hand. If you're doing a hypothesis test using the normal distribution and you're talking about means, your test value is a z-value. Your sample mean minus that proposed mean value divided by the standard deviation. To find your critical value, you would use inverse norm, area to the left, 0 and 1. So let's look at an example. In this example, we have Jeff. Jeff is an 8-year-old boy, and he has an established mean time of 16.43 seconds for swimming a 25-yard freestyle, with a standard deviation of 0.8 seconds. His dad, Frank, thought that Jeffrey could swim faster if he was using goggles. So Frank bought Jeffrey an expensive pair of goggles, and wearing these goggles, Jeffrey swam the 25-yard freestyle 15 more times. For these 15 swims, Jeff's mean time was 16 seconds. Frank thought that the goggles helped Jeffrey swim faster. Conduct a hypothesis test to see if Frank was statistically correct. Use a level of significance of 0.05 and assume that the times for the 25-yard freestyle are approximately normal. Now there's a lot of information there, so what are the important bits of information that we need to make sure we keep in mind? Well, first of all, what claim was being made? The claim is that the new time is faster or less than the previously established mean. Our previously established mean was 16.43 seconds. That standard deviation was 0.8. Our sample mean that we are comparing here, seeing if it is faster, is 16, and our sample size is 15. So bringing these important bits of information forward with us, we also are keeping in mind that our level of significance was 0.05, so we can begin our hypothesis testing. We always start by writing our hypotheses. The null hypothesis is that the mean is greater than or equal to 16.43. The alternative hypothesis is that the mean is less than 16.43, and this is our claim. Now in our second step, we're listing our level of significance. We're given a level of significance here, and on all of your homework problems, you will be given a level of significance. And we can calculate our critical value by using the inverse norm function. We get that our critical value is negative 1.65. I like to draw pictures to go along with these as we're first learning how to do hypothesis tests. So we've drawn our critical value line and listed our critical value and our level of significance, that tail area. Now finding our test value, this is pretty quick to do by hand if you want to. You have 16 minus 16.43 divided by 0.8 over the square root of 15. This equals negative 2.08. And if you're using your calculator, you would find a p-value as well. So doing it by hand, you'd be using your traditional method, the first method we covered. Doing it on the calculator, you could use your p-value method. So on the calculator, you would go to stat, over to tests, and we would be using the z-test here. So we would enter all of our information, and it would give us a test value of negative 2.08, and then also the p-value of 0.019. Now let's draw this test value into our picture. We see that our test value is out in the tail area. We can also compare our p-value and alpha. We see that alpha is greater than p. So since our test value is in the tail area, and because alpha is greater than p, we know that we can reject the null hypothesis. So since we rejected the null hypothesis and the alternative hypothesis was the claim, we're able to say there is enough evidence to support the claim that the goggles make Jeffrey faster. A recent publication states that the average closing cost for purchasing a new home is $7,983. A real estate agent believes that the average closing cost is different than $7,983. She selects 32 new home purchases and finds that the average closing costs are $8,033. The population standard deviation is $392. Help her decide if she is correct by testing her claim at a 0.05 level of significance. Since she believes the closing cost is different than this value, we would have equals and not equals for our symbols and our hypotheses. Now she's saying that it's different than 7,983, so that is the value that we are listing in the hypotheses. The alternative hypothesis here is the claim. We then list our level of significance, which is 0.05. This is a two-tailed test, so we have two critical values. Our first critical value is 1.96, and the other critical value is negative 1.96. We can find our test value by taking 8,033 minus 7,983 and dividing that by 392 over square root of 32. That gives us z equals 0.722, and our p-value from the calculator using the z-test is 0.471. So if we were to draw a picture, list our critical values, and draw in where our z-value is, we see that our z-value is not in the tail area. And comparing alpha and p, we see that alpha is less than p. This leads us to the decision of do not reject the null hypothesis. So we're able to state there is not enough evidence to support the claim that the average closing cost for purchasing a new home is different than $7,983. Now, what if we were to use the student t-distribution because we did not know the population standard deviation? Well, our test value is going to be pretty simple to calculate again. And our critical values, again, not too bad to calculate if we have a calculator that can find these for us. For those of you who have a TI-83, you do not have this function and you would have to use a table. You do, though, have the t-test on your calculator, which would give you the t-value and the p-value, which would mean you would not need the critical value. Let's look at an example. Statistics students believe that the mean score on their first statistics exam is 65. A statistics instructor thinks the mean score is higher than 65. He samples 10 statistics students and obtains scores as follows. He performs a hypothesis test using a 5% level of significance. The data are assumed to be from a normal distribution. So what are the important bits of information we need here? Well, the claim is that the mean score is higher than or greater than 65. We do not know the population standard deviation, so we will be using the student t-distribution. We need to find the sample mean and sample standard deviation in order to proceed if we were going to calculate this by hand. The sample mean is 67 with a standard deviation of 3.1972, and the degrees of freedom is 9. Our level of significance is 0.05. So now we can begin the hypothesis testing. Our hypotheses, the null hypothesis, mu is less than or equal to 65. The alternative hypothesis, mu is greater than 65. And this is the claim. The claim was that the mean score is higher than 65, so greater than 65. Step 2, stating our level of significance and our critical value. Using inverse t, the area to the left is 0.95. We have 9 degrees of freedom. So our critical value is 1.833. Drawing this into our picture, and then finding our test value. That would lead us to the decision to reject the null hypothesis. Now you could also have entered all of those data values into a list on your calculator and perform a t-test using just the data. You then would have got a t-value and a p-value as well, which I did not list here, and that also would have led you to rejecting the null hypothesis. So writing your final conclusion sentence, you rejected the null hypothesis. Your claim was the alternative hypothesis, so you're stating there is enough evidence to support the claim the test scores are higher than 65%. A new baker is trying to decide if he has an appropriate price set for his 3-tier wedding cakes, which he sells for $95.06. He is particularly interested in seeing if his wedding cakes sell for more than the average price. He researches online and finds 22 of the competitors in his area that sell 3-tier wedding cakes with a mean price of $88.77, with a standard deviation of $6.15. Help him decide if he's selling them for too much by testing his claim with a 0.05 level of significance. Writing your hypotheses here, the price at which he sells his cakes for would be what you would be comparing the mean to. So the null hypothesis is mu is greater than or equal to 95.06. The alternative hypothesis, which is the claim, is that mu is less than 95.06. In your second step, you're listing your alpha and your critical value. And then in step 3, you're computing the test value and finding your p-value. You could find this on your calculator as well using the t-test found in stat and then over at tests. Your t-value would be negative 4.797 and your p-value is 0.00005. This leads you to the decision to reject the null hypothesis and stating there is enough evidence to support the claim that the baker sells his cakes for more than the average price of his competitors. Now let's talk about hypothesis testing for proportions. Your test value would be calculated using this formula if you were to do it by hand. And your critical value would be found using the inverse normal function. June believes that 50% of first-time brides in the United States are younger than their grooms. She performs a hypothesis test to determine if the percentage is the same as 50%. June samples 100 first-time brides, and 53 reply that they are younger than their grooms. For the hypothesis test, she uses a 1% level of significance. What are the important bits of information? Well, the claim is that the proportion is equal to 0.5. Our sample proportion is 0.53, and we're comparing to 0.5. Our sample size is 100, and alpha is 0.01. Now, if you were entering this in your calculator using the 1-prop-z test, you would want to enter the number that said yes, so 53, and then your sample size, 100, and your proposed value of 0.5, and then your level of significance. Your example continued, so the important bits of information are here again. So let's begin our hypothesis testing. Our hypotheses now contain p instead of mu because we are talking about proportions. So our claim was that the proportion is equal to 0.5. So the alternative is that p is not equal to 0.5. This is a two-tailed test here. So finding our two critical values using the inverse norm function, and we have our alpha listed here. We find our test value and place it there on our nice picture. And using the 1-prop-z test, you could find a p-value as well. But let's just go off the picture for this one. We see that our z value is not in the tail area. If it's not in the tail area, we decide do not reject the null hypothesis. So there's not enough evidence to reject the claim that the proportion of brides that are younger than their grooms is equal to 0.5. Marketers believe that 64.58% of adults in the U.S. own a cell phone. A cell phone manufacturer believes that a smaller proportion have a cell phone. 32 adults living in the U.S. are surveyed. of which 12 report that they have a cell phone. Using a 0.01 level of significance, test the claim. Your hypotheses should include P. Your null hypothesis should be that P is greater than or equal to 0.6458. The alternative hypothesis is that P is less than 0.6458. And that is your claim, because you're claiming that less than this proportion own a phone. Your level of significance would be 0.05, and your critical value would be negative 2.326. Your test value, if you computed by hand, would be as such. If you use the calculator, you would get the same result for your test value, and your test value z equals negative 3.203, and your p-value is 0.001. You would see, if you were to draw a picture, that your test value is in the tail area. You can also compare alpha and p and see that alpha is greater than p. This leads you to the decision to reject the null hypothesis. Thus, there is enough evidence to support the claim that fewer than 68.58% of adults in the U.S. own a cell phone. Limitations. Hypothesis testing has a few limitations that we need to make sure that we keep in mind. No matter what, there will always be error involved. But by increasing the sample size and decreasing the level of significance, we can decrease the probability of errors occurring. Samples that contain bias can lead to inaccurate results, so we need to be careful about how samples are collected. We should always make a conclusion statement about the results of the study applied to the demographics sampled. For example, if you collected data on student loan amounts from Peru State College, then you can only make a conclusion statement about Peru State College students, not all adults in America. Generalizing the results to all adults in America would likely be flawed, because the sample only included college students at Peru State College, and is likely biased due to Peru State College having a fairly low tuition rate and the fact that not all American adults even attended college, and your sample only included Peru State College students. So be careful when you're making your conclusion statements, especially when you're doing your own research. Make sure that the conclusion statements talk about specifically what you studied.